It says prize money in millions of dollars, so we know essentially what the units are on Y. Awarded for the Indianapolis 500 from 1991 to 2003 is shown on the table below. Let the number of years after 1990, that means this is year 0. And we start at 91, 93, 95, 98, 2000, 2003. Align the data. We'll do a lot of this later on with some of our models. And we start out with 1991 is year what? 1. 93 is year 3. 95 is 5. 98 is 8. 2000 is 10. 2003 is 13. That's why it's kind of nice to start it at a year with 0. Okay? Using your calculator, find a linear model for of the prize awarded as a function of the years after 1990. Call your model P of X. So I'm just going to come down here. I don't know why I wrote an R. P of X. Maybe it's because our next problem is an R. So P of X, and now I need to enter the data into my calculator. And remember how we do that. We do stat, edit, and I've got data in there, so I'm just going to enter in over top of it. 1, 3, 5, 8, 10, 13. I've got leftover. So I'm just going to delete till I don't have anything to delete anymore. Then I'm going to move over to the other one, and it's 7.01, 7.68, and 8.06, and 8.72, and I've lost it, 9.48, and 10.15. Oops, I'm out of stat, edit, go back in here. 9.48 and 10.15, and then delete, and then I make sure these line up. If not, I'm going to get an error message telling me that they don't. And I need to do a linear regression, LINREG, so it's stat. Now I've edited, would mean I put my information in, calculate, down to 4, linear regression, hit enter, and I've got something there that I don't want. That means I'm going to get an error message. So I'm going to come over here, delete this stuff out in front. So it's just LINREG, and enter, and there's my mathematical model. And we said we want to take it to 2 decimal places, so it's AX plus B. A is 0.258, so it's 0.26x, and B is 6.793, so it's 6.79. The correlation coefficient is R, 0.99669. 0.99669 to 5 decimal places. So now I have my mathematical model, and it says, how good's the fit? It's pretty good. And this is why. And how do I know it's close to 1? I have 2 9s. So I have 2 9s, so that says pretty good. Interpret the slope of the line of the line you found above in the context of the problem using the units of the problem. Well, if I look at P of X equals 0.26x plus 6.49, or 79, excuse me. What's the slope? 0.26, and it's 0.26 over 1. So that means that the numerator, if I take a look at the y's in my table, it says the y's are dollars in millions. So this is $1,000,000, and the x is years. So if I interpret the slope for every additional year after 1990, the prize money does what? Increases by 0.26 million. And we'll make that 0.26 million, put the dollar sign in it. That's what it means to, in the context of the problem, interpret the slope, because there's units. It's a rate of change. There's units attached to that slope. It's million of dollars per year. Millions per year. Millions per year. That's why I write it this way, put the units in, and then I write my answer once I have the units in. Because that says, go over 1 year, go up 0.6 million. Go over 1 year, go up 0.6 million. Go over 1 year, go up 0.6 million. That's your slope. Use the model found above to estimate the prize money awarded in the year 2010. 2010 is what X value? 20. So that says X is 20, so I'm looking at P of 20. And P of 20 is 0.26 times 20 plus 6.79, which is, and now I pull out my handy dandy calculator again, 0.26 times 20 plus 6.79, which is 11.99, right? 11.99 what? Million dollars. And would I mark it wrong if you took it to 12? No. You're going to approximate it by 12. This is an estimate anyway. Why? Because I rounded. Still, it's an approximate answer. So if you wanted to take it to 12, that'd still be an okay answer.